Batteries. We know them, we count on them. A battery is, simply put, a unit that converts stored chemical energy into electrical energy. They power the devices we use every day. Our flashlights, our phones, even our vehicles. But what about using a battery to power something even bigger? Like an electrical substation. Reducing purchased power during peak demand times to save members money is a concept that has been utilized by the electric industry for years. Implementing battery storage to serve electric demand is the modern approach to this concept. Incorporating a pilot project in Western Iowa is a concept that has been brought to fruition thanks to the cooperative principle of cooperation among cooperatives and the collaboration of 7 member electric cooperatives in Western Iowa, all members of Northwest Iowa Power Cooperative, or NIPCO. Basin Electric Power Cooperative, which provides power to electric co-ops across the Midwest, including NIPCO, introduced a member-owned trial battery rate in 2019.
Basin Electric started a member-owned trial battery rate in that each of their Class C members could go out, purchase a battery for up to 150 kilowatts of their native load.
The rate allocates up to 150 kilowatts per member cooperative to employ between a substation and the end user.
NIPCO has 7 members. All the members are allocated 150 kW except for one. One of the members gets 75 kW because it's shared across 2 GNTs. Therefore, 150 times 6 plus 75 equals 975 kW, the size that we went with.
This is the catch-all. You hear it in the national media, you hear it in the local media, that we can just shut down coal-fired facilities, we can just shut down natural gas facilities, and it's as simple as just plugging it into a battery, but it's not that simple. So the purpose of why NIPCO and its members have joined together to create one large grid-scale battery is so that we can see how it works operationally, we can record the data, we can find out financially how it works. Does it break even? How long does it take to get payback? It has to make economic sense. We can't just go forward with these new technologies and expect our members to pay for it, without that into consideration. We have to make sure that their best interests are with every decision that we make.
NIPCO, working with its member cooperatives, developed a plan which allows each member the opportunity to pool its battery allocation, allowing NIPCO to integrate a 975 kilowatt Tesla Megapack into the feeder of a single distribution substation within the NIPCO system. The plan enables NIPCO to utilize battery storage as a part of its overall load management strategy.
Everything we do at NIPCO is for reliable, economic power supply. As we go forward with all the national pressure of the regulators, state regulators, everyone's pushing towards renewables, less carbon. The magic key to going forward is battery technology.
The stored power from the battery will allow NIPCO to avoid purchasing almost 1 megawatt of power, enough to power approximately 100 homes, during peak usage times for up to 6 hours.
Another thing that Basin has done that has allowed for this project to get off the ground is the demand waiver period. So at NIPCO, long story short, we buy our power in 2 basically rate components, both energy and demand. And so by the use of the battery, we plan on charging the battery during the demand waiver period. When it's charged up, that basically is cheap. It's almost kind of the beginning of time of day use. And so we are charging it when the power costs less, and then we plan to discharge it when we're in peak times. And so we're avoiding buying power when it costs more. And so that difference, or that delta, is how we're basically not financing, but that's how we're making the economic argument that this is beneficial to the membership of installing this battery.
The operation of the battery will be coordinated with existing load control strategies.
NIPCO has 3 load management strategies. They're called summer, winter, and May. As per the names, they are as per the seasons. We use them all together with the strategy and with the control group to carefully control our peak load. They work very well, and it's based on lots of history and lots of trial and error and experience that we've gained. The load curve, in other words, is basically the load level that NIPCO's Class A members, the full load levels that we have. Our load management system is continuously monitoring that load level or curve, and our load management system has set points that it's comparing that load level to. As the load levels raise higher than the set points, the load management system initiates load shed. Conversely, as it goes lower than the set points, it initiates load restoration. The set points are entered by NIPCO engineering staff, and the set points are based off of weather forecast data and an extensive history of load behavior data.
Chris Larson, NIPCO's system protection engineer, has served as the project manager.
So the battery is going to be used for peak shaving alongside our existing load management program, which we use for shedding load during peak periods in order to reduce our demand charge that we get each month from our power provider.
This new battery system will be incorporated in with the load control groups that we currently have in seasons. Those load control groups and seasons afford NIPCO a significant cost avoidance value yearly.
Larson conducted research into several types of battery energy storage systems known in the industry as best technologies before recommending Tesla Megapack.
There are 5 criteria that we wanted to meet for any substation we were looking at. First, we need to make sure that the load at the station was enough that when we turn the Megapack on, we weren't going to be so low that we're actually pushing back onto the transmission system. Secondly, we wanted to also make sure that it had enough land available. We wanted to also have a feeder available at the station. We wanted to make sure we had communications, good, solid communications. We have fiber at Lawton sub, we have a number of other subs. And then lastly, more or less just public visibility. We wanted to make this so that the public at large could see what we're doing and ask questions, more or less. And Lawton being right on Highway 20 was a perfect fit.
While the Lawton substation serves Woodbury County Rural Electric Cooperative members, the avoided purchased power savings will be socialized across the entire NIPCO membership and ultimately benefit member consumers at the end of the line.
We pass these charges on to our member co-ops, who ultimately pass them on to the member consumers. So anything we can do to reduce costs ultimately gets passed on to the member consumer and saves them money.
In 2021, NIPCO prepped the Lawton substation to expand the footprint of the substation to include a separate fenced yard that houses the battery units. Upon delivery of the Tesla Megapacks in the fall, crews from NIPCO and its member Woodbury County Rural Electric Cooperative worked to connect it with the substation.
They have built the battery to our specifications, but now we're going to get to see, does it actually work in the manner that is beneficial to the membership? We plan on sharing that with the membership. But I'm most excited about what is the information, what is the data that comes out of this new technology, because as we all know, the national narrative, the local narrative is, it's very simple to just shut off a coal-fired facility and plug in on batteries, and it's not that simple. And so I really look forward to informing the membership on how this is working, and so that we're all making better decisions as we move forward into this new generation portfolio that we're going to have to obtain with less carbon emissions.
NIPCO hopes its battery storage project will serve as a shining example of the many ways it works with its members to serve Western Iowa more efficiently and sustainably. In an ever-evolving industry impacted by tighter restrictions on energy generation and an emphasis on reducing carbon emissions, battery technology has the potential to be a valuable component to balance power supply and delivery with the growing demand for reliable and affordable electricity.
This is part of our future.
NIPCO is charging forward.